Welcome to Simply Scripting. I'm your host, Dorex Delicioso. In the last episode, we learned how to take our Read Notecard script from episode 4 and add states to it. I hope you can see the benefits of those states, even if it is just a bit more work. With this, the final episode in the Notecard series, we'll take a look at linked messages. What linked messages allows us to do is to execute code in different scripts in the same object. You no longer have to have all your code in one script. Another way to ensure separation of responsibilities in your code. We'll start with a new base template script, then we'll add the whole script we made in the first episode. Just drag and drop. Pretty easy. We'll add a bit of code to the Notecard script, but it's just for intercommunication between scripts. We're not changing the functionality at all, so let's get started. I've gone ahead and created the standard cube. I've renamed the cube, and added a new base script, also renamed. So, now what? First, we're going to drag our script from episode 4 right into the cube. Drag, drop, done. I'm going to rename it, just so it's not so close to the name for our new main script. And because I forgot when preparing for this episode, we'll also add our default note card to the cube. There, now we're set up to write some code. I've opened up our new main script and added a title and description, which is always a good thing to do. Now, what do we want to accomplish here? Let's think it through. All the functionality we've had up until now is click the cube, get the output. So, let's keep it working that way. We'll start in the touch start event. When someone clicks the cube, we'll send a message to the Notecard reader script to execute its code. Good place to start. We use the message-linked command to communicate with other scripts. Looking at the wiki page tells us everything we need to know. message-linked is a function with no return value. It takes 4 parameters. Parameter 1, link, is an integer value. Parameter 2, number, is also an integer value. Parameter 3, str, is a string value. Parameter 4, id, is a key value, but we can send a string there if we wish. Okay, nothing we haven't seen before. A little further down the page, we see what the value of the link parameter means. That's a lot to understand, and we're going to ignore it. Make life easy. Number, str, and id don't seem to be anything of significance according to this wiki page. Here, we see 5 constants we can use. Here's what they mean, and how they are associated with the link parameter. These constants refer to what prim you want to send the message to. Using link root, our messages will only be heard by the root prim. Link set will broadcast any message we send to all prims. Link all others will broadcast any message to all prims except whichever prim is sending the message. Link all children will broadcast any message to all prims except the root. Link this keeps the message within the prim that sent it. Using these constants we can limit the exposure of our message. The less the exposure the better. Since we only have one prim that we're using, we'll use the link this constant. As we mentioned before, we'll add the message to the touch start handler. We'll add some dummy data to the message-linked command for now, just so the script doesn't complain. Right now, if we clicked our cube, a message would be sent to this prim. message-linked sends a message, but who's out there to hear it? If a tree falls in a forest and nobody is around to hear it, does it make a noise? In the case of message-linked it does, loud and clear. Executing the message-linked command puts an event into the queue. When it's time for that event to get executed, it will cause a link message handler to be called. Link message is just like the touch start, state entry, or any other handler. The handler gets called and it gets passed some data we can access. We know this stuff, right? The link message handler is the handler that will hear messages from a message-linked command. We'll add that handler in our Notecard reader script. The link message handler is going to contain almost the same data sent from message-linked, in the same order. The exception is in sender number. We set a value telling the script where to send the message to. In link message the sender number value will be the number of the prim that sent the message. So, let's add a say debug to see what we're getting in our message. That's quite the say debug message, but really, we're just concatenating all the values into one line. I updated the LL message linked in our new script to send back some dummy data, just so we can make sure we're getting everything correctly. Be sure your doDebug variable is set to true in your Notecard reader script for this. Save, click, test. We can clearly see that whatever we send, we get back. As expected. Bonus. What we got back that we didn't expect was the data from the Notecard. We haven't told the Notecard script to read yet. What's going on? Our Notecard reader script still has a touch end event wired to read the Notecard. As soon as we touch the cube, both our new script as well as our Notecard script get the event and execute their touch handlers. While this may seem like it works, it really isn't very good. We want more control over when the Notecard is read. Seems to me all we have to do now is make our Notecard script listen for our messages at the right time. Going back to our Notecard script, we'll find the touch events. We can easily get the Notecard reader to run by moving the read Notecard command from the touch handler into our linked message handler. Now we can remove the whole touch start handler so it doesn't get confused when we touch the cube. Now, save, click, test. There we go, as expected, we are reading the Notecard. All done right? Put a ribbon on it. Finished. Oh my darlings, you know that's not true. Our script listens for a message, then reads the Notecard. But it listens for any message. We want more control over when things happen than that. In our Notecard reader script, we know that the value 1 is being passed into the number parameter. We'll just check that number is equal to 1 before we read the Notecard. If we only ever send a 1 to mean read a Notecard, we're golden. Let's try it. Now, save, click, test. Yup, still works. Let's go back to our new script and change the number it sends. Now, save, click, test. There, the Notecard isn't being read now. We know if we send a 1, the Notecard will be read, otherwise not. Sending a number and then checking for it is a good strategy, but we can spruce it up a bit. In a large program with lots of messages, I defy you to come back in 6 months and know right away what the difference between sending the number 1 and the number 2 is. We have to make it clearer to ourselves, or anyone else who's reading the script, what's going on. You'll spend more time adding, updating and fixing your script than you will writing it the first time, so anything we can do now, to save ourselves headaches in the future is time well spent. Here's a time-tested strategy we can implement in our script. We'll add a variable, let's call it command read Notecard, and assign it the value of 1. You can call it anything you like, that's just my naming convention. Now we can take that variable name and replace it with the 1 in our LL message linked command. Halfway done. Now, we want to make sure our Notecard reader is listening to the same language our sender is using. We copy the new command variable and paste it into our Notecard reader. Then, update the value we're looking to match to number in the link message handler. Now it's much clearer what value we're looking for. They're done. Now we know our Notecard script will only ever execute on a command read Notecard value. It doesn't matter what that value is, as long as the sender and receiver both use the same value, the same language if you will. I like it, it works. But oh, it can be so much better, can't it? Let's rip it apart and change things around, this is getting fun. While we have our Notecard reader script open, let's make one more change. One more, for now. We added the variable command read Notecard to help us understand what value we're looking for. But num equals command read Notecard doesn't seems very obvious what num is. We'll rename the parameter in the handler to something descriptive. Let's call it command. There, much clearer, isn't it? Our script as it stands will read one Notecard. We don't even get a choice of Notecard names unless we edit the Notecard reader script. One of the benefits of using linked messages is we, or other consumers of our script, shouldn't have to edit an existing, known working script. Let's copy the variables from our Notecard reader that held our Notecard names. Why type when you can copy, right? I bet you can see where we're going. We'll take one of these variables and put it into our LL message linked command. Like so. Now, we just have to update our notecard reader to understand that we're passing a command value as well as a name value. We can start by changing the parameter name from str to notecard name. Much more descriptive of the data being passed in this variable. And finally, we'll pass that parameter to our read notecard call. Save, click, test. Done, completed. Finished. We did good. Let's think a bit. Maybe we can have some more fun before we're done. While what we have works, it's limited. It really will only read and process 2 notecards. What if we needed to read a third one? Right. Let's look at what's stopping us from doing that. We can pass in any name from our new script to our notecard reader script, so that's working. The link message will update our variable to whatever name we send it, so that's working. The problem to me seems like it's in our data server handler in our notecard reader script. It's making a call to select notecard, which is specifically looking for 2 notecard names, as well as data and the EOF flag. There. That's the problem. We don't need to select a notecard any longer, so we can copy a section of code from select notecard and paste it into our data server handler. Since the data server handler is only ever going to get requests for reading notecards, we no longer need the compare data request ID. Now, it's a simple matter to update the process notecard data and end of notecard functions. In process notecard data, instead of doing any processing here, we'll send all the data back to our new script. But how? We send a message here, surely we can send a message back. So what do we need? 1. We need to know who to send the message to. 2. A value telling the receiving script what kind of command this is. 3. The notecard name we're reading, and 4. The data read from the notecard. Hey, we can do this, we have all those values available to us. Let's add these lines. That should send a message back to the caller. Now, we've taken care of process notecard data, we only have to fix the end of notecard function. Not really very much we have to send back, is there? So we'll just send a command value telling the script we're done reading the notecard. We can add another command variable. Let's call it command end of notecard, and give it a different value. Now, we add a ll message link command to send the value back. We'll send the notecard name back. I'm not sure we'll need it, but it won't hurt to send it. The only thing left is a bit of cleanup. The whole select notecard function can now be deleted. And we can remove the variables that contain the notecard names. Now, we have to add the same new command values to our new script, just so the scripts understand each other. Then, we add a new link message event to our new script so it can hear messages. We can update the last parameter name to show it's returning data. We'll have 2 commands being returned here. So we can use a conditional to determine which one we received. Now we need a function to determine which notecard we're supposed to process. We can call it process notecard, and pass it the notecard name and data we got from the notecard reader. Inside this function, we'll send the data to the correct notecard processing function, based on the notecard name. Since we already know the names of the notecards, we can use the variable names they were assigned to earlier. We'll skip back to the link message handler and add the call to our new process notecard function, giving it the name and data passed here. Phew. So many changes. It will all be worth it in the end. Now, we have to do the same for the end of file process. We've already added the command for the end of file. We can create a new process end of notecard function, and pass it in the notecard name. Just like the process notecard function we just did, we'll use a conditional, along with the notecard's name to determine what function will process the end of file. Going back to the link message, we can now add the call for the end of notecard function. Almost done. Almost. So the framework, or scaffolding, is done for us. All we have to do now is add the functional parts. We have 2 notecards and each has data and an EOF to take care of. We are going to need 4 functions. These functions aren't special by any means, but I think I'm going to add a new section in the comments, just so we can keep like-minded functions together. Since all four of these functions process something, I think a good name would be notecard processing functions. If we were to ever add another notecard in the future, it would be easy to spot where these go. We don't have really good names for our notecards, so we can just make up some function names. For processing the data, how about notecard 1 process data? I know. Superb name. Then we can call the other one notecard 2 process data. You can see where I'm headed with this. Can you guess at what the names for the end of file function names will be? How about notecard 1 end of file and notecard 2 end of file? I'm just going to make the shells for all four of these really fast, as I'm sure you're getting tired of this. There, that was easy. We can call the correct function now from within the process notecard and process end of notecard functions. Again, a quick paste over the code will be good enough, I think. Pause the video if you need a moment to see what we did there. The last thing we have to do is fill out how the notecard data is processed. Again, we're just going to echo the data back to the screen, so we'll add the say debug back along with the code to clean up the data we built earlier. And for the end of file process, we'll just say we're finished. That's it. Really this time. That's all, folks. Save, click, test. There it is, all our data, exactly the same as it's been for the last 3 episodes. I did have one question put to me. Where do I add the line to read a different notecard? Very good question. Thanks for asking. You might think adding another link message with the new notecard line would go in the touch start event. That's reasonable to think. But notecards don't always get processed one after the other. The script will try to process them at the same time. While that may or may not work, it won't always. The better place to add a call for the second notecard to be read is right after the notecard 1 end of file function has returned. Like this. This makes sure the first notecard is all done before the second one starts. This type of thing is common in scripting for Second Life, and just something we have to adjust to. Again, thanks for the question. Questions and comments are always appreciated. If you have a suggestion on something you'd like to learn, you can IM me in World or email me at dorexdelicioso2@gmail.com. I truly do thank you for watching. My name is Dorex Delicioso, and I stand behind all my code. Bye for now.